So here we have to find curve of intersection of these two surfaces. And you know that's just going to take ingenuity that I'm losing with age, but then experience and inspection, which I'm retaining some. So anyways, what I'm trying to do is now that I'm trying to solve for one of the variables here and then just go ahead and take that as a parameter and see if it takes us anywhere. So here we can do this. Take say x equals t. And now this one is just very conveniently dressed up for us because what it shows is that if x is t, then we got our y plus z, which is x, and that equals t. And we can extract that y square plus z square in here in the following manner, that here we can split this z square as z square plus z square. And now what happens is that y square plus z square is t, and we know x is already t. So these substitutions are going to yield for us x square will be t square, and then the next again, this y square plus z square would be t, and then we would have, what would we have? Z square, and that minus 7 equals 0. So now we can go ahead and solve for z square and then for z. And let me just bring the final calculations to you. So z square is 7 minus t square. And that gives us what? That z is plus or minus this quantity. All right, so we got x equals t here, and z equals plus or minus that expression. Now we can go ahead and use one of the equations, say this one. All right, so here what do we get? We have x equals t, and we got our z square equals this quantity right here. Okay, so what will that give us is that y equals plus or minus this expression. Now it will depend on, like, because these are, you know, the two surfaces that we have, actually this surface right here that we have, okay, and even this one for a function of z, there we will have to go through the implicit procedure. And so whether we choose plus sign here or minus sign here or otherwise will depend on the region where we are doing our calculations. So for example, say we have to find equation of tangent line to curve of intersection, which will be given from these calculations at this point, 2, -1 and 1, which you can verify is a common point between these two surfaces. So when we do that, so we know our x equals t, that's no problem. Okay, now when we are looking at our y coordinate, then we see that we have y equals -1. So here we are going to choose the negative sign, and when we are looking at our z coordinate, you can see that is 1 here. So we are going to use the positive value here. So this is going to be an equation of our, the parametric curve, that passes through 2, -1, 1, and we have to find equation of tangent line at 2, -1, 1. All right, so what we have is that this is the position vector of the trace of our curve, and what we are going to do is that we shall take the derivative to find the vector parallel to the tangent vector at this point. So leaving the details of the calculations on you, I'm simply writing the derivative as, I just differentiated the three components with respect to t, and now we shall write parametric equation of the tangent line at this point. So how would we do that? First, we have to calculate this r prime at t equals 1. So if we calculate the value of r prime at t equals how much? 2. So when you do that, you have at t equals 2, of course, 1 is going to stay as 1. And if you do all the substitutions, that's what you get. And notice this, that this vector is parallel to negative 6, 5. Let me just bring it here because we have to write line that passes through this and is parallel to this vector, right? Okay. So equation of that line will be what? X equals 2 plus 2t. And likewise, we can obtain y equals negative 1 minus 6t and z equals 1 minus 5t. So let's just go ahead and graph these and see how good our results are. So I have already prepared the script for MATLAB based on these, and that I will include in the, as I said, description of the video. So here we are. We have all the plots, and remember this, shouldn't forget to introduce the syms. So see what we get. Okay. Oh, I see. I did not say hold on here, so it graphed the surface at in a different window. But here we can see that the line is tangent to the curve of intersection, which is available here for a very small segment. But anyways, let's just go ahead and say hold on, and so that we get everything in one window. All right, so here we are. Okay, and it should. So you can see that here is a curve of intersection and there is tangent line.